Hello everyone, welcome to part 1 of session 3 of module 4, specification based or black box test design techniques. So in part 1 of session 3, we will learn about following specification based or black box test design techniques. What techniques we will learn in this part 1? We will learn about equivalence partitioning and boundary value analysis. So let's get started. So let's first understand what is equivalence partitioning. Equivalence partitioning is a black box test design technique. It can be applied at all levels of testing. So equivalence partitioning can be applied at all levels, at the unit testing level, at the integration testing level, at system testing level. So at all the levels of testing, you can apply equivalence partitioning to design your test cases. So unit, integration, system, acceptance, at any level of testing, this technique, this black box technique can be applied to design your test cases. Then what is the idea behind equivalence partitioning is to divide or to partition a group of test conditions into a set that is considered same by the software. Okay, so suppose there is a text field in a web page in your web-based application which accepts some range of numbers. Some range will start from some valid number and end from some and at some valid number. Okay, so suppose it accepts just numbers from 1 till 100. So as the name equivalence partitioning is pretty self-explanatory, so since your software, the text field in the software accepts a range of some numbers from 1 to 100, so this range of between 1 to 100 is a valid partition. So you partition, you design your test cases in such a way by partitioning the valid and invalid partition. So that text field will accept the numbers between 1 to 100, and there will be two invalid partitions for that text field. One will be anything less than 1 and the other invalid partition will be anything greater than 100. So that's the fair bit of idea how equivalence partitioning is done and how you do it and how you design your test cases by using equivalence partitioning. We'll take more examples as we go ahead. So we need to test just one condition from that partition, as it is assumed that all the values in that partition will be treated in same way. So in that valid and invalid partition, you need to just test one value from those partitions, because it's assumed that all the values in those partitions will be treated in a similar way. So that's the idea behind equivalence partition. Rather than just testing randomly the inputs randomly, it's always a good idea to test invalid partition, valid values from invalid partition, valid partition, and invalid partition. So that way it's you have a better coverage of the software. You cover a lot more partitions rather than doing a random test of input, of making an input of any number in the text field. Then if one of the value in a partition will work, then we assume that all values in that partition will work. That's the idea behind equivalence partitioning. And if one of the value in that partition fails, then it is assumed that all the values in that partition will fail. Then these conditions may not always be true. However, testers can use better partitions and also test some more conditions within those partitions to confirm that the selection of that partition is fine. So this is not hard and fast thing that you should always test one value in one partition. So there has to be a mix and match, and you should design your partitions in such a way that you are covering almost all the partitions, and then you should also try more values within those partitions and make sure that everything is fine. Then equivalence partitions are also known as equivalence class. So if somebody asks you what is equivalence class, it is same as equivalence partitions. So let's take an example of equivalence partitioning. So suppose there is a store e-commerce website which offers different discounts on different purchase amounts. So if the purchase amount is in the range of $0 up to $50, so and I have taken the dollar amount up to 2 digits, so it's 0.00 to 50.00, so up to 2 decimal places, and if the purchase amount is over $50 and up to $200, the discount percentage is 5%. If the purchase amount is over $200 and up to $500, discount percentage is 10%. If purchase amount is above $500 and up to a maximum, so there is a maximum limit defined as well, purchase limit, so the discount will be 15%. So now you have separate purchase amounts, which is kind of a range of the purchase amount, the amount of the dollars you spend, and then there is a discount percentage. So now using equivalence partitioning, if you want to design your test cases, you can easily create the partitions and you will be able to figure out what values you want to test in those in these scenarios, rather than just randomly inputting any purchase value and verifying the discount, which is not the right approach. So the right approach is to design your test cases using equivalence partitioning properly and then test each valid and invalid partition. So we have seen that if purchase, the second line on this page, if the purchase is in the range of 0 up to $50, then there are no discounts. So first partition you can think of is the purchase amount will start from $0, so 0.00 up to $50, so 50.00. So that's one valid partition wherein you will get no discounts. All right, then the second partition will start from 50.01, so that's another partition for which you will get 5% discount. So 50.01, as we have taken 2 decimal places, so 50.01, any purchase which starts from 50.01 up to $200 will be in the valid partition of 5% discount. Then there will be a partition of 10% discount, that is also a valid partition, which will have the range of 200.01 to $500, so that will be 10% discount. Then another valid partition is for the 15% discount. So valid partition 15% discount, which is for the purchase of $500 plus up to maximum limit, maximum purchase limit. So 500.01 up to maximum purchase limit. So these are 4 valid partitions: no discounts, 5% discount, 10% discount, and 15% discount. So any purchase above maximum is not allowed. That means that is an invalid partition. All right, and any purchase below $0, any negative value is not allowed, and that is also an invalid partition. So you have 4 valid partitions and 2 invalid partitions in this case. So this, applying equivalence partitioning in this scenario, made your task very easy So now you can test some values in this invalid partition in negative. You can check the negative, what's the outcome when you enter any negative purchase amount, what's the outcome when you enter any valid partition which is less than $50 or up to $50, you should get no discounts. And for 5% discount, if you enter any value between 50 and 200, you should get 5% discount. If you enter any value between 200 to 500, you should get 10% discount. And if you enter any value between 500 and less than maximum, you should get 15% discount. And any purchase above maximum plus 0.01 should again be treated as invalid, and it should be handled properly by the e-commerce website or the portal that you are testing. So this is one example of equivalence partitioning, how you do equivalence partitioning for any application. So the next technique that we'll discuss is the boundary value analysis. So as equivalence partitioning was testing valid and invalid partitions, now boundary value analysis is any input or output value on the edge of an equivalence partition. So in equivalence partition, we have seen an example that from $0 to $50 there was no discount. So what boundary value analysis is? Boundary value analysis checks the behavior of the software when you enter input or output, when you check input or output at the edge of the partition. So suppose the valid partition was 0 to $50, 0.00 to $50.00. So the boundary values for that valid partitions will be $0.00 to and $50.00. So these are two boundary values for that valid partitions. So boundary value is any input or output value on the edge of the equivalence partition. Boundary value analysis is based on testing at the boundaries between partitions. So boundary value analysis is based on testing at the boundaries. It has nothing to do with the values between the valid and invalid partition. It just tests the values at the boundaries. And boundary value analysis is a black box test design technique where test cases are designed by using boundary values, and BVA is used in range checking. To apply boundary value analysis, you need to take maximum and minimum values from valid partitions. So as we saw in the previous example, the valid partition, first valid partition was 0.00 to $50. So you need to take maximum and minimum values from valid partition. So minimum and maximum value from first valid partition were 0.00 and maximum was $50.00, and together with first or last value respectively in each of the invalid partition adjacent to the valid partition. So if the text field on your web page accepts values between 1 to 100, so boundary value analysis will take tests as, so the first value will be, minimum value is 1, maximum value is 100, and then first and last value from invalid partition. So invalid partition would be any value above 100. So the last value above 100 is in the invalid partition is 101, and the first value in the invalid partition adjacent to the valid partition is 0. So in this case, wherein your text box accepts value between 1 to 100, you will be having 0, 1, 100 and 101 as your boundary values. So let's take an example to understand this better. So suppose you have a text field, as we discussed. We discussed about 1 to 100. Now on the web page, we in this example I have taken up to 1 to 1000. So if a text field accepts values between 1 to 1000, so the valid partition will be 1 to 1000. All right, and the invalid partition will be anything less than 1. Okay, so it will be 0. Since it just accepts the integer values, so it will be anything less than 1 is integer value is 0, and integer value above 1000 is 100, 1000, 1 and above, and that is also invalid because the text field accepts only between 1 to 1000. So boundary value for this example would be 0, 1, 1000 and 1001. So in the previous slide we have seen that minimum and maximum of valid partition, and then first and last value respectively in each of the invalid partition adjacent to the valid partition. So the first and last value in each invalid partition. So first value in the invalid partition is this this is the first value in the invalid partition, and that's the kind of 0 is another value in the invalid partition. So 0, 1, 1000 and 1001 are the values that you can test in boundary value analysis. So let's take another example to understand boundary value analysis. So we have taken up the same example as we discussed previously for equivalence partitioning. So iStore City offers different discounts depending on the purchase amount. So if purchase is in the range of $0 to $50, no discount. So it's exactly the same example. So we have seen that valid partitions were for the no discount, 5% discount, 10% discount and 15% discount. And invalid partition was anything above maximum purchase limit or anything in the negative, as a negative purchase was the invalid partition. So now we'll see what are the boundary values for this scenario. So boundary values will be, for this partition, the boundary values will be $0, and the maximum in this equivalence partition is $50. For this partition, 5% partition, the boundary value will be 50.01, anything above this, and the other boundary value will be 200. All right, so let's see what all boundary values will be there for 4 valid partitions and 2 invalid partitions in this case. So here if you see, so the test condition is first is the purchase amount and discount purchase percentage. So these are the test conditions. So we have seen that there are 4 valid partitions. First valid partition was between 0 to 50, wherein no discounts were offered. Another valid partition was between 50 to 200, wherein 5% discounts were being offered. Third valid partition was between $200 and $500, for which 10% discounts were offered. And the last valid partition was between $500 and up to maximum purchase limit, for which 15% discounts were offered. And the invalid partitions were anything less than $0, all right, or anything greater than the maximum purchase limit. So these were 2 invalid partitions. And discount percentage, what will be the discount percentage invalid partition? Any other value you can say, or non-integer or non-interest calculated. So anything other than these discounts is invalid partition for discount percentage. So let's see what will be the valid boundaries. So valid boundaries, first and last value of first valid partition, so 0 and 50. Then another valid boundaries for another partition, first and last value of another partition, so 50.01 and 200. Then for third partition, valid partition, boundary values will be 200.01 and 500. And then for the last valid partition, 500.01 and maximum purchase amount. So these are the valid boundaries. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 boundaries you will get for 4 valid partitions. And what will be the invalid boundaries? Anything less than 0. So you can say 0.01, all right, or negative value, and anything above maximum plus 0.01. So these are 2 invalid partitions. So what you can say is, so in this case you need to test these 8 values for this scenario of discount in a store, and 2 invalid boundaries to make sure that error handling is done properly for any invalid boundaries, and for any valid boundaries and partitions your discounts are being calculated perfectly fine. All right, because it is seen that most of the software break at the boundary values. So that is why you should always test boundary values as well as some of the values in between those boundaries. So apart from these 10 test cases, you should also test some of the values between these valid partitions to make sure that everything, all other scenarios are perfectly fine. So the advantage of doing equivalence partitioning and boundary value analysis is that it is a structured approach, and it makes your test design much more efficient and easier, and you are almost covering every possible partitions and boundary values that are possible in that particular scenario. So why to do both equivalence partitioning and boundary value analysis? So equivalence partitioning and boundary value analysis exist together whenever you are working in an enterprise application testing, or in any testing organization. You do not do just equivalence partitioning or boundary value analysis. You do both of them together, and they are always done together. It's because testing only boundaries does not give much confidence, as we are testing just extreme values of the partitions. So if you're just doing one thing, if you're just doing equivalence partitioning and checking few values in between randomly and not checking the boundaries, or you are just checking the boundaries and not the values in between of the valid and invalid partition, so that does not give you the complete confidence. So that is why both equivalence partitioning and boundary values are very important. They are done together. It is important to test some values in between the partitions as well. So that is why it's not only just test extreme values, but some values in the partitions. So it is recommended that partitions should be tested separately from boundary values, and it is always recommended that partitions should be tested separately from boundary values. And if you want to be more thorough, then start with valid partition testing, then invalid partition, then valid boundaries, and finally invalid boundaries. So both equivalence partitioning and boundary value analysis has to be done together, and you should start with valid partition, invalid partition, then valid boundaries and invalid boundaries. So all your test cases should have both techniques covered in order to make sure that you are covering all aspects of the of equivalence partitioning and boundary value analysis and testing the software properly with these techniques. So to conclude, in this session we'll learn about specification based or black box test design techniques. We'll learn about equivalence partitioning and boundary value analysis, and we also understood why we need to use both equivalence partitioning and boundary value analysis together to design our test case, and how these techniques will reduce your extra effort that you put while you are doing random testing. If you just input any values randomly to test these kind of scenarios, it's not sure that you are covering all the partitions and all the boundary values. Unless and until you apply these techniques, you are not sure that you have covered all the partitions and all the boundary values. So it is very important when you start designing your black box testing test cases, you apply these techniques in order to make sure that you are covering both the test design techniques for designing your test cases. Thank you.